Now we're going to look at a molecular formula problem. In a molecular formula problem, a lot of students get a little bit overwhelmed with this process, but really there's not too many more steps than there are to solving for an empirical formula. And actually, the first step of the problem is to solve for the empirical formula and to use that information to solve for the molecular formula. So our given information, we're going to do problem 10A from the test review packet, is 94.1% oxygen, but we're going to convert that into grams. We're going to assume that we have 94.1 grams of oxygen and 5.9 grams of hydrogen. So we're going to assume we have 100 grams of compound, and we're going to take that number, convert it into moles. And take this number, convert it into moles. So grams will cancel for each of those. We're going to plug this in. At 5.88 moles of oxygen. .85 moles of hydrogen. Now these are close enough where we can assume that they are really about the same, so there might have been some sort of experimental error in measuring these, or possibly rounding differently can adjust, can affect the number that you get in the end. So these are really close. These are about, so this is going to give us a 1-to-1 ratio between the two elements in this compound. So we can say that we have this compound. This is the empirical formula. Okay, and its molar mass, we have to find this, is 17 grams per mole, so you have to look that up. Now the reason why we need to know this is so that when we write down the molecular formula, we can say, well, the molecular formula has, this is given in the problem. It has a molar mass of 34 grams per mole. So in a problem like this, you're going to be given the molecular formula's molar mass. Okay, and since it's twice as large as the empirical formula molar mass, that means the molecular formula has twice as many atoms in it. So it's actually going to be a 2-to-2 ratio, and it's going to be H2O2, which is actually hydrogen peroxide. So the way we figured that out is, well, the molar mass is twice as big, so we have a multiplier of 2, and we determine that by looking at the molar mass. So that's the reason why you need to find the empirical formula, is so that you could say, well, we're going to multiply it by 2 so that we can get the molecular formula from that molar mass comparison. Okay, so this is the key step right here.